So PMAC can also do electronic cam tables. And basically the table-based commanded motion as a function of another position. You can have up to 256 total cam tables stored simultaneously. The size is only limited by the total amount of memory, as it is with other PMAC features. And then there's 3 separate outputs from the table as a function of this master position, which is the source for your table generation. So you can modify the output, the commanded position or position offset for the target motor. You can also torque offset for the slave motor, and then a general purpose output word. So you can have synchronous outputs that go along with the cam table. The outputs are computed every servo cycle, and it's third order interpolation between points for the position and the torque output. Of course, there's no interpolation of the outputs because those are just digital I/O. Automatic indefinite rollover for the table in both directions. And then position and torque values, they are floating point, scalable units. And it's very easy to offset both the source and target position references, and easy to switch from one table to another. So the overview of the structures involved here, you tell it the source motor number, again the number of zones that are in the table, the starting position of the source, and then the span of the source position. And then structure elements that about the target motor. So there's the target motor number, there's the position output scale factor, and then there's the torque offset output scale factor. And then there's the elements for the actual entries for the cam table. So pause data sub I, DAC data sub I, and out data sub I. What is the individual general purpose output value? Because it's pointing to a multi-bit register, and so you give it a multi-bit value, and it changes those bits every time it goes through the table. Some people use these tables just for that purpose alone only, to cycle through these outputs, to clocking through a set of outputs based upon a commanded position. So the source motor for the cam table, it must be from a power PMAC motor, and we put motor in quotes because it could be a virtual motor, a software generated motor. It has to come from desired position, so that's why it has to be a motor. And that's specified by camtable.source. The source motor should be in a separate coordinate system from the target motors, because you don't want the source motor to be subject to the target motor's error modes, fault modes, and alike. And it can be from an actual physical motor controlled by power PMAC, or it can be from a position sensor for motion not controlled by power PMAC. But the sensor has to be used as position feedback in power for the power PMAC virtual motor. So basically, you create a virtual motor that's using that sensor as feedback. So the motor has to be activated so it can process the feedback, but you wouldn't enable it because it's not an actual, it's a virtual motor. And then the sensor position is automatically then copied to the motor's desired position, which is then used by the cam table. We support both returning and non-returning cam tables. So a returning cam table where the start position and the end position of the cam are exactly the same. Like a reciprocating linear action from a table. An example of a real-world example would be if you were to electronically control a valve in a motor. That would use a returning cam table, because it always goes from closed to fully open and back to closed again. But you may want to control the velocity and the rate of how it changes along its range of travel. For example, in a really souped up motor, you usually have these very lopey cams, that have a very high rise, and then they slow out real very slow at the other end. So the thing can open up and let all the exhaust out, or open up and let all the explosive gases in. But each cycle of the table will cover the same range. So that's a non-returning cam table, on the other hand, has a different beginning and end position. And so this would be typically used on a rotary action from a table. So you have your source that's continuously going, and then there's some rotary action going on, like let's say a specialty polishing operation where it doesn't end up at the same spot every time. It ends up at the next spot. And then each cycle of that table would cover a different position range. Now, the torque offset and the general purpose output values, of course, are always returning. They don't have the knowledge. There is no scheme by which they wouldn't be returning. So here is graphically, the y-axis is the target motor cam position, and the x-axis is the source motor position. And then if we take a look at the non-returning cam position action, we can see that there is a number of these parallel cam actions that can happen depending upon where the actual start was. The general purpose outputs, there's a cam table P out that specifies the destination register for the outputs. And then there's also what we call P out buff, which specifies an address of a holding register in case we want to be able to read back the values. We cannot read the P out, but we can read what we specify as the holding register for P out buff. And then out bits specify the number of bits to control. It must be consecutive bits in the word. And then we have a left shift that specifies a shift of the table value before writing, which is typically set to the LSB used in the output register, the number of the number of the LSB in the output register. Boy, I hope I don't lose my voice before the end of this. I'm getting really close. We can adjust the cam table reference positions. And I think what I'm going to do now is I'm going to jump over here to the other hand, to the last handout I just gave you. Where did I put that? Oh, it was right there. There we go. Now, one of the things about a cam table, because you could do similar features with, and you guys did talk about time base a little bit earlier today. You could do similar features with time base, and time base would give you, would definitely give you a little bit better control over, creating a digital or an electronic cam table. But time base can only go in one direction. Time base can only go in the forward direction, whereas a cam table can go forwards and backwards. And the motion is defined by a table, not a program. Motion of multiple motors must be defined by multiple tables, but you can have up to 256 tables, so that's not an issue. Because it's not a motion program that you're running to generate in time base to do an electronic cam, you don't have the ability to do any logic during the execution of the table. So these are some of the things that you might want to question yourself if you decide you need some kind of cam table. Do you want to do it as external time-based, or do you want to do it as a cam table? Do you need logic or point computation during the execution of the table? In the table, the points must be evenly spaced. And the cam tables, let's see, why am I not getting... Cam tables have direct torque offsets. And I think what I'm going to do now is just pop over here to the executive. Now, all the features of the cam Sculptor exist in the IDE, but if you want to be able to output your cam values, you do need to purchase a license. It's the only part of the IDE that has a purchased license requirement, is the cam Sculptor. But I think you're going to see it's a pretty sophisticated piece of software. So basically, when we go in to the cam Sculptor, we can tell it whether it's a returning or a non-returning. We can go in and view the setup parameters, so we can tell it the cam table number, the source motor number, the target motor number, the number of cam zones, the length in each zone, position scale factor, any position offset, the slew that we want, and then the output buffer that we want it to go to, the output word that we want it to go to, and possibly the output buffer, and the number of output bits, and then how much we want to shift. Since we're going to do all 32 bits, we don't need to shift. So this will generate my cam. And then if I had this was a licensed version, I would be able to export this. We could go now and we could view my cam positions. Now, right now, I could only view these values in here. I could transfer them manually, but in order to get them, there isn't. You notice the download has been grayed out, so I can't download these to my Power PMAC.